All right, welcome everybody to our first in our riparian series. This is really exciting. I'm going to give you some background and some introductions, and then we're going to dive right into the presentation. Let's see. Hey, Hans.
Hey, BY.
Hey, did you know about the Beaver documentary that I saw last night?
No, tell me about it.
It was the best damn program I've ever seen. They're going to get worse. All right, so I'm going to tell you a little story. About 4 or so years ago, a group of us were working on a creek cleanup in Rapid City, and it was a beautiful spring day. It was cold and blustery, and the snow was blowing sideways. And as we worked in the creek, we pulled out garbage bags full of Safeway bags and bottles and shopping carts and even a walker. And we decided that a 1 day a year creek cleanup wasn't enough. And so a group of us committed to doing creek cleanups once a month at minimum. And now we do them on the second Saturday of each month. Thank you. But with that, it was selfish because we came at it from the perspective of trout fishers. And we wanted to be able to catch more trout in Rapid Creek. And so that started an investigation of stream flows and water quality here in the Black Hills. The Black Hills fly fishers, along with conservation groups, policymakers, and government agencies, have been working diligently on habitat restoration projects throughout the hills. It's good work, but we can't do enough of it. More work needs to be done, and we want to share some of that work with you and expand our boots on the ground as well as our educational efforts. The work illustrates a need for more education about water quality, quantity, and security. And it also led us to develop this riparian restoration series of events to help educate stakeholders about the importance of keeping cold, clean water on the landscape here in the Black Hills. We have an exciting slate of speakers that will be coming here to Rapid City, either in person, like Dr. Fairfax, or virtually right here at the Journey Museum. Understanding how stream systems work is important for several key reasons. Flood prevention and management, water quality protection, ecosystem health, sustainable development, climate change adaptation, and wildfire mitigation. You got a problem in your watershed? We've got a beaver for that. Hey, Hans.
Hey, BY.
What does a French beaver call her home?
Geez, I don't know. What does it call it?
Madame. That was a rough one. Riparian restoration efforts create a healthier and more resilient ecosystem. This work could not be accomplished without the help of our sponsors. We appreciate all that you have done for us. Many of you are here in the theater with us tonight. Give yourselves a round of applause. We would like to thank the Black Hills Fly Fishers, the Black Hills chapter of Pheasants Forever, the Black Hills Sportsman's Club, Dakota Trout Unlimited, Isaac Walton League, Lost Cabin Brewing Company, Northern Great Plains Venture, the Black Hills Environmental Coalition, South Dakota National Wild Turkey Federation, the Prairie's Edge Trading Company, South Dakota chapter of Backcountry Hunters and Anglers, the South Dakota Wildlife Federation, South Dakota Youth Hunting Adventures, the Mule Deer Foundation, the Nature Conservancy, the Norbeck Society, and Snag Entanglements Limited. If your organization would like to help, see one of us after the show, and we would love to take your money. Now, this is particularly exciting. I want to introduce to you our good friend, Eric Zimmer.
Good evening, everybody. Welcome. My name's Eric Zimmer, and I work at your friendly neighborhood Black Hills Area Community Foundation. We at the Black Hills Area Community Foundation have a 3-part mission. and it is to lead solutions, to give with purpose, and to thrive together. And tonight, I think there's a culmination of all three of those things happening. And I just want to tell you very, very briefly about it, and I promise not to keep you from Dr. Fairfax any longer than I have to. So when we talk about leading solutions, how many people were here when Ben Goldfarb gave his talk last year? You might recall during the question and answer session, a very rude person blurted out, "We should have a fund to pay for this kind of work." That rude person was me, and we decided to do it at the Community Foundation. So last fall, we started the Beautiful Black Hills Fund, which is a pot of money that we use to support strategic projects that pay for outdoor and natural spaces work across the Black Hills. When we say lead solutions, we don't mean we're at the forefront. What we are good at is finding the people who are doing the work and giving them the resources that they need to be successful. And that leads me to point number 2. So when you think about Hans and BY and all the different folks who are doing this BDA work and watershed restoration work, we thought, how can we give with purpose? And so over the last several weeks, what we've been doing is raising money. And I have a very big check right here for $36,000 that we're going to give to support watershed work throughout the Black Hills. There's a couple different projects here. So this is BDAs on Silver and Gimlet Creeks that are being installed this summer, planting 6,000 willow trees and tubing them so that they make it through the winter and can hold back water and continue that work. A range camp for some professionals who are learning how to do this work and expand it throughout the region, and then a documentary film project that's going to capture this and help us tell the story to be able to do more of this. In addition to the tens of thousands of hours of volunteer work and hundreds of thousands of dollars in public and private funds that have already gone into this work, Hans and some other folks reached out to the Community Foundation a couple weeks ago and said, "We have this $46,000 gap to fill. Can you help us do it?" We put up half at the Community Foundation. We have a number of donors, including the Black Hills Environmental Coalition, a couple anonymous donors, myself, our CEO, Chris Huber, all put in our own personal money because we believe in this. And we got to 36,000, which means we have 10,000 to go. If you're interested in supporting this work, the QR code up there will take you right live to a place where you can put dollars in the Beautiful Black Hills Fund. And any money that goes in there over the next 48 hours will go straight to paying for this work, right? So we're very honored and excited to do that. And the last piece of our mission, as I said, is to thrive together. When we have cold, clean, and connected water, we all thrive. Our habitat thrives. We have better drinking water, refilled aquifers, healthy landscapes, healthy waterscapes, and we're able to, over the long term, take care of this place that we all care about, build a culture of stewarding the Black Hills, and survive in a high quality of life deep into the future. So thank you all very much for being here. Consider supporting this important work. And if I can have Dr. Fairfax, BY, Chris, and Hans come up, we're going to do a big check presentation, which is the cheesiest and best part of my job, and Sterling's going to take a picture of it.
Let's do it right in front of the big screen. All right.
Get that out there. Get your beaver shirts going. It's on to you, Sterling.
I'll get to you though.
Yeah.
I knew.
Thank you.
Cool. Thank you.
Thanks, everybody.
Thank you, Eric. Thanks, sir.
Our first event in the Riparian Restoration Series tonight will be a presentation by Dr. Emily Fairfax, Beavers, Architects of Resilience. Dr. Fairfax is among the premier experts in her field. Getting her to Rapid City to present is absolutely amazing. To have this caliber of academic to talk about the things that we're passionate about is really cool. So we're excited to have you here. Emily Fairfax is an assistant professor of geography at the very famous University of Minnesota. And an affiliate faculty member at the St. Anthony Falls Laboratory. Dr. Fairfax double majored in chemistry and physics as an undergrad at Carleton College, and then went on to earn her PhD in geological sciences with an emphasis in hydrologic sciences from the University of Colorado Boulder. She uses a combination of remote sensing, modeling, and fieldwork to understand how beaver ecosystem engineering can create drought and fire-resistant patches in the landscape under changing climates. Her research has been featured internationally in the National Geographic, the New York Times, the LA Times, PBS, NPR, BBC, Vox, and others. When Dr. Fairfax says she can talk about beavers all day long, she is not kidding. Hey, Hans. I keep mistaking beavers for other river mammals.
Why is that?
I oughter know better. I know that it may pain some of you to see me give up the microphone. But without further ado, it is our great pleasure to welcome Dr. Emily Fairfax.
All right, I am super excited to be here today to talk to y'all about my favorite thing, which I genuinely can talk about all day, beavers. So it's getting hotter. What a great day to make this statement. Every single day feels like it's hotter, it's drier, it's just not quite as nice as it was last year. And that's a true thing that's happening. It's not just what you're feeling. Every single decade is hotter than the last. And we're seeing the air temperatures rise more and more every single year. And as they rise, it's not just that it's hotter and maybe I can't hike quite as far without having to drink a little more water or put on a little more deodorant. Maybe the issues that we are needing to think more about isn't the warm air temperature, it's how these air temperatures are leading to increasingly damaging disasters. So unfortunately, every degree warmer we get more intense fires, we get stronger and longer droughts, and we get catastrophic flooding. When we get the water we want, it's the wrong time of the year, it's too much, too fast, and it's a problem. Now, I've worked as an engineer in the past, and humans are one of the brightest species that have ever existed. We've engineered our way out of so many challenges. And this is an engineering challenge. I can say that with the utmost confidence. This is an engineering problem. I can also say with the utmost confidence, we cannot do this engineering alone. It's too much for us for the first time. We may have 10,000, 20,000 years of experience engineering the physical Earth, but that's kindergarten compared to this other engineer out there that's got about 7.5 million years. And that's the beaver. So we can sit in our academic towers and on our high horses all we want, thinking that we are the best engineers out there, but we have a lot to learn from this large, somewhat awkward, semi-aquatic rodent. And beavers are really the solution here. When we think about these disasters, when we think about this warmer planet that we're living on, we need to be looking to beavers and learning from them. And if you're thinking, hold on just a second, beavers and these disasters, beavers and fires, beavers and droughts, beavers and floods, there's a mismatch here. This doesn't feel like peanut butter and jelly. This doesn't feel like salt and pepper. And I would agree, you don't usually talk about these kinds of things in a sentence together, but hopefully after today's talk, you will. Now, I want everyone to take a moment and think about what our rivers and creeks look like today. You're probably thinking something like this. These are what our streams look like. These are our creeks. These are simplified. These are what we're familiar with. Now, most of us can agree that this is not necessarily what they should look like. When we think about what our rivers and creeks and streams should look like, we usually think about something from the past. So imagine what they did look like in the past. Try to put that picture together in your head. And when a lot of people do this, their minds drift to historic maps. And they think about what was drawn, and they think about these stories they hear about the rivers, about the streams, about the ways they flowed. And as much as you want to think about that, there's a really good chance that as you make that mental image, something is missing. Now, I'm a river scientist. I got my PhD studying rivers. I think about rivers all the time. I'm also a physicist. I love putting equations and numbers and laws to describe nature. And I'm in good company in the field of river science. Starting in about the 1880s, all of these big names, Strahler, Horton, Hack, Powell, Davis, and Gilbert, started looking at the rivers all across North America and describing them. And trying to say, this is how they flow, this is how floods work, this is how erosion works. And they developed the entire field of river hydrology and river ecology and river geomorphology. And then it kept growing as we went through the late 1880s and into the 1900s. We're really just describing everything about rivers. We are understanding this system. And right when this field started, something really big was actually missing. Something had been very recently removed from the landscape at a very large scale. And what I'm talking about is beavers, and it was actually a much bigger change than sometimes people know. So beavers have been beaving around for a really long time. In fact, beavers have been building dams on North America for at least 7.5 million years, and it's probably more like 24 million. We're not exactly sure when they developed that dam building behavior, but 24 million years ago they were cutting trees, and 7.5 million years ago we split the North American and Eurasian beaver into two different beavers, and they both can dam, so it had to be before that. This is a geologic timescale that beavers were operating on. We've modified the Earth a lot in the last 200 years. Beavers are also really powerful engineers, and they've had 7.5 million years to make their footprint on the landscape. And their footprint is big. You're looking at a map right now of all of the streams and rivers across the lower 48. Every blue line is a waterway, and 53% of those are our headwater streams. Every single headwater stream was full of beavers. Every single headwater stream was full of beaver dams. Almost every single main stem river was also full of beavers. Maybe they didn't dam as much on these bigger systems, but they were there. We had between 100 and 400 million beavers in North America. They were operating at geologic spatial scales and geologic temporal scales. We had about 1 billion beaver dams on this continent. Now, if anyone here has ever tried to permit a dam of any kind, or any kind of a pond, really hard to do. How many billions of years would it take us to permit 1 billion dams? Probably a lot. It didn't take beavers that long to do that and then maintain it for eons. And it only took us about 100 years to erase that. We trapped beavers down to maybe 100,000 across the entire continent. And as we did that, their dams broke and everything washed out. The maintenance crews were gone. We had a continental scale reshaping of the rivers. It took off in the early 1800s, and by the mid 1800s, early 1900s, they were gone. Their infrastructure was gone. And that's when we developed river hydrology. That's when we set the norms for what our streams should look like. It was not what they had always been. It was the disturbed state. Now today they're coming back. We're back to maybe 10 to 30 million beavers across North America. This is great, 10% of that historic population on average. But this is not evenly distributed across North America. Some places are coming back strongly, some places have a long ways to go. And we need to think about where they are and where they could be, because every single beaver is an architect of resilience. Every single beaver can help us figure out our way out of floods, out of droughts, and out of fires. So this is a typical beaver dammed area. We have a lot of different things going on in this. There's upland species, pines and conifers. There's these riparian species, grasses, weeds, reeds, shrubs, riparian hardwoods. We've got the beaver's lodge, that dome they live in, the dam. There's fast water, there's slow water, shallow water, deep water, warm water, cold water. It's a mosaic of habitat. This is what we had 1 billion of in North America. And this is what beavers will do today, given the opportunity. And there's a lot of opportunities because this is what our streams look like today, for the most part. Really simple, single threads. Sometimes they're a little wiggly, sometimes they're perfectly straight. They're basically a conveyor belt for water. And as this water moves through them, and there's nothing in its way to slow it down, it cuts that stream deeper and deeper and deeper. And it puts it in this cycle of degradation. It's hard for us to engineer our way out of that. We try, we can. It's expensive, it takes a lot of time. Whereas a beaver rolls in, just builds a dam. Doesn't pull a permit, doesn't do a NEPA assessment. It just goes and builds that dam. And as it does that, it slows the water down. And it gives it time to reconnect to the floodplain. And you build back up your riparian ecosystem just a bit. Now, busy as a beaver is a phrase for a real reason. It's not just a fun alliteration. They're absolutely not going to stop once they've built one little dinky dam. First of all, they're going to expand it. They want that dam to be longer, taller, stronger. They want more aquatic area. They want deeper water, colder water. This is what the beaver is going for, a nice big patch of water. Quick show of hands, how many of you have seen a beaver in real life? Love it. Put your hand back up if you've seen them walking on the land, not swimming. Fewer hands. Expected. Beavers are a semi-aquatic rodent, meaning they live both inland and on water. So for those of you that haven't seen them on land, there's a good reason for that. Beavers weigh anywhere from 40 up to 110 pounds. Their body is shaped like a bowling ball. They have a paddle tail off the rear end, webbed back feet, and hands on the front. When they try to walk across the landscape, they are waddling. It is not safe for them to be out waddling around like that. Evolution has taught them that. All of these things that make them awkward on land make them extremely safe in water. They can hold their breath for 15 minutes. They can outswim essentially any predator. They are in their safety zone in the water. And so that's what they want to be, in the water. That's why they make this dam bigger, more water. But sometimes they have to go a little farther away. Sometimes they have to get a tree from out in the forest. They're not going to just haul up on land and say, well, I hope I make it back today. They learned from evolution that strategy does not work for them. So instead, they do something that I think is the most underappreciated beaver behavior. They dig. And they dig canals. These are little microstreams that radiate outwards from the beaver's pond across the valley bottom. They're only about a beaver width wide, and they are oftentimes much more than a beaver width deep. But you won't know that when you're walking up to them because they're very hard to see. So these are their aquatic highways. This is what the beaver swims in and around to be safe. This is what they float their logs home with to build, just like we did during the timber era. Now, all of this building up until the canals makes a wetland patch. But once they add those canals, they have re-wetted the entire valley bottom. While the dam might be 100 feet, 200 feet long if it's an impressive one, canals can easily be half a kilometer. And there's hundreds of them in an active beaver complex. They're irrigating the landscape in a really big way. So just to make sure we have all of our terms straight, and that we understand what this looks like in sort of 2D, this is your beaver wetland. We did a great job with the beaver in the water looking slick and agile. We got those beavers back on the land looking like chicken nuggets, chewing on their trees, very vulnerable. Beaver in the lodge, separate structure than the dam. That's what they sleep in, that's what they groom in, and then the dam is holding back all of the water. I would say that this is a good representation that a beaver dam makes a pretty big change relative to the size of a beaver. But I would also say that drawings like these really undersell just how influential beavers are. So those are two of my field assistants on top of a beaver's lodge, and you're watching the drone increase in altitude. And we're just starting to see one of those beaver dams come into image over here. And the drone rises and rises. We have our canals snaking off through the landscape, intersecting one another, and then the second dam starts to come into view. This is one beaver family. This one beaver family is maintaining about 14 of these dams. They're working 2 kilometers of the stream. Imagine what it was like when we had 100 to 400 million of them. It was completely different. Now, this poorly named Otter Creek is home to a lot of beavers, and much of it looks like this, and it's a great place for beavers. It's wide, they can really control things, and this isn't what all of our streams look like. Some of them are quite steep. And when beavers can't expand laterally and create this vast, wide wetland, they don't give up. They engineer in the other direction. So instead of going wide, they go long. And instead of building just a couple of really huge dams, or maybe 14 really huge dams, they decide instead to build 30, 40 dams per kilometer up some of our steeper drainages. Every single one of these is deep in holding back water. They're basically engineering locks and dams here, but they did it a long time before we did. This particular string of beaver dams goes all the way back to the exact origin of water, the actual headwaters, immediately dammed by beavers, all the way down the stream. When we get this damming in sequence like this, now beavers are operating at a scale that is comparable to wildfire and drought and climate change and flood and our larger regional and global disturbances. And it's through all of the complexity that they build into the landscape that we get this sort of resilience effect that is so uniquely awesome and uniquely beaver. But how exactly does that work? We've got these big crazy wetland patches. What does that do to create drought or fire resistance? It actually starts during your flood period. So as soon as you have a stream that's gotten degraded, you have a narrow riparian belt around it, this stream is vulnerable to high water. This is different than our stream with beavers, where we have a lot more complexity, we have the canals. I want to be clear here that the canals also connect upstream to downstream. This is a big question. Are they just going outwards? No, it's more of a spider web of canals rather than like a starburst shape. These are fundamentally different hydrologic systems, and when we have too much water at once, whether that's a true flood, a flash storm, a lot of snowmelt, whatever's causing high water, if it's going through a degraded channel like this, it's too powerful. And you get a flood wave. And your flood wave is going to rip your stream apart. And it will take chunks off the edge. And it will dig the stream deeper into the earth and make it more vulnerable next time. This is a feedback loop of increasing degradation. But if you have a beaver wetland on there, it disrupts that cycle. You have your flood wave encounter deeper water and wider water. Those canals that are so effective at moving the beavers are also effective at moving the water out onto the floodplain, which, as its name suggests, is for floodwaters. And then it interacts with all this dense vegetation. It slows it down. It combs the debris out of the floodwater. And it still goes downstream. They don't build with concrete and rebar. This is not watertight. But it does slow it down, and it does give it a little bit more time to sink into the soil. So instead of seeing this massive scale of erosion and soil loss and scouring, instead what we see is water being slowed and stored and spread out. And that's what we need if we want those other two types of disasters to be mitigated, the droughts and the fires. Think about your streams again, without beaver and with beaver, but this time we're looking with depth, into the earth. Now I've set our water table pretty deep. You have to dig far if you want to hit groundwater in most of the West. And that's just the way it is. And a lot of our plants, their roots are not able to reach true groundwater. They might be able to reach the shallow groundwater, they might be able to reach our seasonal stores, but true groundwater is often out of their reach. Our streams, when they're degraded, have a pretty small impact on our shallow groundwater or our soil water system. They just don't connect to it very well. There's not time for water to soak out into the soil, and so you just get this narrow wet band. Where we have the beavers, you have a much wider pond, but then every single canal they dig is a microstream. Every single one is basically pinning your groundwater up at the surface, which the plants do not care about when it's raining. As long as it's raining, the plants are watered from above, they're happy, they're healthy, they're green, it's fine. We are often not in our nice rainy periods, we are often in our drought periods. And as soon as you enter that drought, you take away that precipitation from above, everything is relying on soil water. And when we don't have it because the stream's not healthy, because it can't hold the floodwaters back, then they don't have it when it's dry. And they start to wilt and wither and shut down. But the beaver wetland was so good at slowing that water down and getting it into the soil that the plants can keep drinking it up through their roots, even if we don't have rain. And I've studied this in Nevada, in some of the driest places that I can find. And in my studies, we had a 3-year severe drought, and the beaver wetlands did not lose any of their vigor during the entire drought period. They were much more comparable to the irrigated alfalfa fields than they were any other part of the river network. This has also been studied in Canada and boreal ecosystems. This is a widespread effect of beaver damming. We know this, we say this with confidence. They are uniquely drought-resistant patches of wetland. And that matters so much if you have an abandoned campfire, or a lightning strike, or a power line that misfires, and you get a fire. Because fire is going to burn whatever is dry and whatever is crunchy and crispy, and unfortunately, that is a lot of our river corridors. When they are unhealthy, they are a wick for fire. We see them burn into the river bottom, we see them destroy that ecosystem in some cases, and completely demolish the riparian vegetation, making it more vulnerable to erosion and all of those problems during your next flood period. But the beavers never felt the drought because they dealt with the flood, which means they can resist the fire. Now, if this feels like a logic leap, or maybe this model is not doing it for you, hopefully a photo will. So these are from my colleague, Dr. Joe Wheaton at Utah State University from the Sharps Fire, which burned in Idaho back in 2018. In our streams without beavers, the fire came down the hill slopes, went straight through the valley bottom, and back up the other side. And all these little white blotches you see here are ash piles from willow. And it is completely destroyed. And you walk through these landscapes and you have to be careful because there's holes in the ground where roots used to be, and it sinks and collapses. And you can burn off your seed bank in some of these fires. But if we had beavers, which we did, the fire comes down the hill slope and it stalls. It cannot get in. It's just too wet to burn. And ultimately this one blew to the other side and went up, but that riverscape was protected. And when you zoom in and look at it more closely, it didn't even matter that this one was a little wiggly. It didn't even matter that we had 2 threads instead of 1. It was still vulnerable. But when you add beaver dams and when you add beaver canals, you create fireproof patches. And it's not that the fire was burning kind of weak here. It was still very intense. There's one of those burned willows. But once it got into the real area of beaver engineering, it was done. It could not burn that part. And this is what I've been really focused on for the last 10 years. How are beavers doing this? Is this something that happens consistently, or was this a rare effect? Are those Idaho beavers just super lucky? I started by putting together a study to look at 5 fires across the American West, and at the time of this study, I thought these were really big fires. I don't think that anymore. I will come back to that. But they were good-sized fires, right? And what these had in common was beavers. There are beavers within every single one of these fire perimeters. What else they had in common? They had fire. Everything other than that, there was a ton of variance. We had variance in how dry it was beforehand. We had variance in the land cover. Was it grass? Was it forest? Was it pine, deciduous, coniferous? What was going on here? All of that variability made me think, okay, I will find the situations where beavers can create fireproof patches and the situations where they cannot. In what environmental contexts does this work? To answer that question of can they keep things green, I want you to imagine that you go to all my study areas and you walk along the creek. And you're going to do this from a designated starting point to a designated stopping point. And you're going to do it before the fire, then you're going to do it again right after the fire. This is basically what I did, but since I don't start my own fires and I don't know when they're going to begin, I couldn't actually do this on ground, and I used satellite instead. So while you would be staying super close to the river and writing down, where do I see beavers, are things green, I'm doing this but with satellites. And so I'm going back in time and I'm pulling out pixels to see, is it green? And then I'm mapping the presence of beavers and all of their infrastructure in super high-res imagery. And I'm going to show you a little bit of my results from the Mantor Fire, which burned in California back in 2000. And this was in Sequoia National Forest in the area called the Domeland Wilderness. It's very rocky, and outside of the rocky areas, we have some conifers and some scrub. And the beavers are thriving there. That is me with a beaver dam. And that picture was from 2019. So the beavers are at least back in this landscape, but that doesn't mean they made it through this fire. It was a big fire, 79,000 acres, but it's also a lot of beaver engineering. Here's one of their complexes with many beaver dams. Here's their lodge. That's 60 feet across, for reference, 60. A very big beaver lodge in California, minimum of $1 million lodge, I would have to say. So they're really living large up in the Domeland, and they're up against some really big fires. And when I'm going into these studies, I get very excited about the idea of getting some cool data out and trying to do some analyses, and I'm a big numbers dork, so I'm excited to see the actual numbers come out. But it's also helpful for me to take a step back and try to figure out what it was like to be there during these events. So I like to find news articles or interviews describing these specific fires that I study. And I'm going to read you a quote from the LA Times that was written about the Mantor Fire while it was burning. It is a humbling expression of nature. Walls of flame, 70 feet high, twice as high as the nearest tree. Leaping through canyons and valleys, at times in 5 directions at once. Left behind, quite literally, is scorched earth. Now, this is not an exaggeration. Since doing this study, I have lived through wildfires living in Colorado and in California, and I have seen 70-foot walls of flame. And they are intense, and they are scary. And that's what beavers are up against. That's what they were up against in 2000. That's absolutely what they're up against today. So this is a big ask. Like, maybe those Idaho beavers were just lucky. But I don't know till I look at the data. So let's see what it says. I'm going to show you a plot here. Now, on our x-axis, on the horizontal, that's the distance along creek profile. So here's your designated starting point, and then you walk, 4,000 meters out. That's a good length walk. And then you're done. And on our y-axis, that's the plant greenness, NDVI, normalized difference vegetation index. Basically, a lower number means there's less or fewer green plants. Higher number means there's more green plants. So as you walk, you say, lots of green plants, and you point it up here. And then if there's no green plants, you'll put it down here. Before our fire, the data looked something like this. And this kind of data is meaningless unless you look at it day in and day out. So I'm going to add a line that should provide some meaning. I expect it to be above 0.3 when it's healthy riparian zone during the growing season. So mostly we are above that threshold. There's a couple spots that dip below, and I did go check out what was going on there, and they are boulders. There's big old boulders, and there's not a lot of plants growing on the boulders. So that's okay. They're allowed to be below the 0.3 threshold. And then we do it again after the fire comes, and the greenness data looks a little different. For a while, it seems like it was doing okay, and then it just plummets, and it stays below the threshold the entire time. And then we put the position of beaver dams on the x-axis. And then if we look where the beavers were, and we look where the beavers were not, there's a pretty big difference in how we had the fire affect the ecosystem. And to make that difference a little bit more clear, here is the difference plotted. So a lower number here means we had less burning or less fire effect, and a higher number means more. Where we had beaver dams, we saw fire suppression. We saw fires being blocked. And as soon as we get away from the beaver dams, it burns. And We saw this in every single creek, in every single beaver dam, in every single fire in every single state. I did not achieve my goal of finding when and where this happens because the answer so far was everywhere, which was great. I published this in a paper. I titled it Smokey the Beaver. If anyone has ever tried to publish in peer-reviewed literature, that's my crowning achievement, is getting that through peer review. Scientists don't like fun, so getting that one through was tough. But it got through, and I was talking about these results. I found that the beaver-dammed areas were burning 3 times less than the places that didn't have any beavers in them. And I spoke to some folks in the Forest Service, and I was on a webinar with them talking about this. And I said, man, I wish I could have been there during the Mantor fire. Would have loved to have seen this. It was such a profound effect. And someone on the call was like, oh, fun, I was there. And I flew burned area emergency response. And guess what we took a ton of photos of, because it was the only thing green. And so I got all these photos of the beaver dams in the Mantor fire, where we had walls of flame 70 feet high consuming the trees, where we had, quite literally, scorched earth, and where we also had refugia. We had patches that weren't burning, and it was where the beavers were working. Even though I wasn't there, and even though I did trust my satellite data quite strongly, seeing this was really impactful. And they didn't just take these highly zoomed out photos, they also looked to see who else was there. And it turns out a lot of things benefit from having unburned patches. Things like this black bear, who is hunkering down in basically the grocery store now, with fresh, clean water and lots of other things that he can be eating. And I like to show this because it proves that this isn't just for the beavers. They are selfishly engineering, but the impacts of it really do benefit us all. I also show this because I can make my worst joke, and I'm going to take the title for worst joke today, which is that Smokey Bear got a helping hand from Smokey the Beaver. This is my favorite one. Forest Service didn't like it so much, but I'll get there eventually with them. So at this point in my research, I'm pretty much sure that I've peaked, and I've solved the wildfire crisis, and I'm ready to retire. And then 2020 happened, which was a very hard year for many reasons, including it was one of the worst fire years we've ever had. And then the next several years after that, it just kept getting worse. And we are in the age of megafires. And it's been really easy, and I've lived all over the US, for places to say, okay, but not here. Okay, but that's California. That's Oregon. That's someone else's problem. But it's our problem here as well. This is the fire risk and the wildfire likelihood in South Dakota. And red is high. We are in very high risk. And sometimes you think, oh, well, I'm in a state that doesn't have that high of risk. Here's some white pixels. This isn't where I'm talking about. Everywhere over here is very high risk for fire. So we need to be thinking about this because a lot of places don't think that this is going to happen to them until it does. And megafires are different. This isn't the same kind of fires we've been dealing with for a long time. Megafires are fires that have a burn area of larger than 100,000 acres. Now, I want to be clear, fire can be really good for an ecosystem. We need it in many places. And being big doesn't necessarily mean a fire is bad. What means a fire is bad is when it gets to be that size because it's exhibiting really extreme and self-sustaining behaviors. It burns so hot so fast that it makes its own weather system. And instead of getting a classic storm cloud that makes rain, you get a classic storm cloud that rains fire, and ember, and ash. And those make secondary fires that merge with your primary. And then that makes your fire bigger and stronger, and it makes ones that create fire tornadoes. Now, being in Minnesota now and also having lived in Indiana, I know for a fact we can't fight a normal tornado. So we are not going to be fighting a fire tornado. These are really challenging systems. And when they burn that hot that fast, when they make their own weather systems, they're burning 100,000 acres in a day. We can't get ahead of that. It's too fast. And they leave behind these huge swaths of moderate and severe burning. It's stand replacing fires. It's 60,000 acres of high severity altogether. It's too much. And that's what beavers are up against now. And so I wanted to know, can they create fire refugia, these green patches, that would persist even through the most extreme fire behavior? Now, for better or for worse, Colorado had not had megafires of any real note for about 100 years. And then in 2020, they had 3, all at once, that were threatening to merge with one another. And they were the Cameron Peak, the East Troublesome, and the Mullen fires. And I'm showing you their burn severity here, and red is high severity, and you don't need to know the other colors, because it's just red. These were really difficult fires. East Troublesome burned 100,000 acres in a day. Cameron Peak and East Troublesome both jumped the Continental Divide, which we would think is a great barrier to fire. Turns out it wasn't enough. This is what beavers are up against. And I had a lot of beaver dams to look at here. The Mullen Fire had almost 1,000 satellite visible beaver dams, Cameron Peak 99, East Troublesome 512. Now again, I'm thinking, I will find when and where beavers cannot create fire refugia. I will know under exactly which conditions, which riverscapes does it not work in, which ones does it work in. Because I have some of the worst fires we've seen on landscapes that were not ready for fire. Now we do see them stay green pretty often. So I use satellites to find beaver dams. If you have done this too, you've already found them in this image. I know my lab sitting up in the front has already found them, and if they haven't, we're gonna talk. But if you haven't, just wait till the landscape burns, because then it's really easy to find them. They are these little black blobs. Those are the ponds, and they're the only thing that has greenery around them. So we can see this. In this study, I wanted to not just see this, I wanted to really cleanly quantify this. So I used a new satellite measure called DNBR, the differential normalized burn ratio, that calculates the burn severity at every single pixel, every single spot in my landscape. And here I will tell you, blue is unburned, or it's growing even better the next year. And we have some blue in the landscape, but we also have lots of that red. Now, doing this study, what I ultimately found was that the beaver complexes are really fireproof. 89% of them were fire refugia by area. When you were in the river and there were no beavers, the number was 60%. And when you were outside the river, it was 37. So they're clearly providing a very strong fire refugia effect. But what about the 11% that didn't have this strong fire refugia? What was it? Two things. First, it's actually just the edge. So as the fire's coming in super high severity, it's gonna burn a little bit, and it takes some space to go from high severity down to nothing. So we get a little bit of like fringe burning around our wetlands. That's fine. The wetland core is still preserved. It's still fire refugia as a complex, but maybe not every pixel. The other thing that happened is we did have a handful of beaver dams burn. And unfortunately, those ones had just been built that year. So these beavers came in, built their dams in August or in July. Fire starts in September. They didn't have time to store water. And so they didn't have that first step of building resilience, and it wasn't the right timing for them. And luckily, it was only a handful of dams, because once those dams had been there for a year, they were able to provide the refugia. And we saw this in a big way in our fires. We saw bands of beaver dams. We saw beetle-killed forests going up in smoke. And we saw them unable to cross sometimes. And so these kinds of things, it's great refugia, but there's also places where we're seeing a new phenomena. It's not just protecting a patch, it's actually changing the fire. So now what we're really looking at is, can these beaver wetlands stop fire? And I'm going to tell you, we don't have a full answer to this question yet. It's something we're just starting to work on. We want to know, when do we get fire refugia, or patches, and when do we get fire breaks, or actually stopping fire? Now, to be clear, a lot of the time we are going to have refugia. So fire comes up, it stalls, it blows over, it keeps going. We have a lot of wind in these fires. That's one of the reasons they get so bad. Embers are going to blow. And the beavers cannot work every single part of the landscape, so this is not necessarily beavers failing. This is just maybe beyond what they can handle. Except sometimes we did see the fire come up and then stop, and it did not get through. So what's going on there? To answer that question, we've started mapping out fire spread. And so what we do is we go in and we find all the beaver dams. Here they're mapped in pink. And then we pull satellite images at the highest frequency we can, using a lot of different sources, to try to find out, how does it spread? Over time, we have fire come down, press into the river corridor, try to get in, multiple points along the way. It is not that it's blowing in the other direction, it's absolutely approaching the beaver wetland, but it can't cross. So what happened here is we had a boatload of beaver dams. This is a big valley bottom, and it is packed with beaver dams. This is a wide fire break. It is great to have kilometers of fire break, and when beavers are in there working, it's really reliable. So sometimes, yes, beavers can stop fires. There are circumstances where this occurs. So far, we're seeing really wide corridors and also lower canopy fires. We can see some of this fire breaking. But also sometimes no. Sometimes we map out the dams and the fire direction is parallel to the direction of the beaver complex. And so since all the lines of fire movement align with the lines of beaver dams, it just kind of skirts around them and then ultimately just leaves sort of this string of unburnt. We get refugia, not stopping. And so if the direction of fire doesn't match the direction of damming in the right way, we're not going to get fire breaking. There's not much we can do about this one. but there are situations where we can do something about it. So here we had the fire coming in all sorts of directions. We had a lot of directions of beaver damming. And what happened was the fire broke through in places that didn't have as much beaver activity. It broke through in the places that were less restored. And so if we can patch some of these breakthrough points where we only have a couple of beaver dams and they're older and they're broken down and maybe they're not active anymore, if we can go in and do this riparian restoration, we can take ourselves from refugia to fire breaking in more scenarios. But can we? Is the real question, right? So we know beavers can, but what if we pretend we're the beavers? What if we mimic them and not like this? This is how I do field work when I have a team taking the real data. What about if we build beaver dam analogs or beaver mimicry structures or fake beaver dams? For those of you that don't know, this is not the mad ramblings of a strange woman at the podium. This is something we actually do quite a bit of. There's whole design manuals about how to be the beaver, how to mimic these things, how to create the same structures that beavers do, and we honestly do the best we can. And I want to be clear, when we build BDAs, the goal is to bring back beavers. They need to be there. Damming is just one part of the fire resilience story. We also want canals. We also want tree chewing, even though that's a common source of conflict. That's also fuel thinning. So we want to get to this state, which we know is fire resistant, but we also want to know, what about these three sort of transitionary periods? Are they fire resistant too? And I'm just going to show you a little bit of my preliminary data from the Ridge Fire that burned in California this past year. It was a small fire, about 2,700 acres, and this data is preliminary. We're still working on it. But basically what we had was Sulphur Creek is running here, and all the little tributaries into Sulphur Creek are very degraded. And one of the BDA builders I know, who's really good at his job, and he is about as close to a human beaver as you can get, went in and built a ton of structures here. We know beavers would build 20 to 30 dams per kilometer in this landscape, if they could. So he goes in and he builds 20 to 30 structures per kilometer in this landscape. And then luckily for me, not for anybody else, a fire came through, and the fire burned this restoration site. And we looked at the burn severity, and we wanted to see, where did we get fire refugia patches? And the only patch in the entire fire was the restoration site. Now, maybe it was just innately fire resistant. Maybe we didn't do this, right? So how do we figure out if we did it? What we need to do is compare our fake beaver site to a very similar site that we did not do any restoration in. And I'm going to show you the greenness curves for these two places, the stream that has BDAs and the stream that does not. But first, I'm going to show it to you before the BDAs were built. So the stream that would ultimately have them is in blue, and the stream that was going to be my control is in gold. We're looking at that greenness again, and now X is time. We expect in a healthy system to have a rounded seasonal arc of greenness. Things should green up when it's warm and sunny, and then green down when we lose the sun. If we see what's more of a shark wave shape, we're looking at drought stress, which is what's happening here. It greens up during spring. It should kind of arc like this, but there's no water, and that's a big part of photosynthesis. We have enough carbon dioxide, and we also have enough sun, but since there's no water, it drops off. So both of these streams are drought stressed before the BDAs went in. It was innately a little bit greener, at least during the dry years. And then we had a wet year, and it flipped, and the other stream was greener. And so basically we're seeing these are functionally pretty identical streams before restoration. Then we restore them. And remember this threshold, 0.3. We want to stay above that as long as possible. That's healthy, that's green, that's growing. We do the restoration, and we green up, we start our drop off, but then it's a different shape. We get this sort of puffed up part in the later summer. We stored enough water to maintain greenness in a way that our control stream did not. And then the ridge fire burns. And it was not felt at all in our restoration site. And it was felt in a big way in our unrestored streams. So we can build that fire resilience if we really think about how would a beaver work in this landscape and then do it ourselves. And we should put that time in because these patches are so important. It's important for the beavers. I made it very clear early in the talk that they're an awkward animal on land. They're not outrunning a wildfire. They need these patches to stay safe. They need this healthy green willow. They need this cool, clear water. This is the view you would have had from a beaver dam as a fire went through. You can see this was a high canopy fire. This was a severe fire. This was a smoky, hot, terrible fire to be in, and this patch was safe. And I've visited this site many times. The beavers lived, they had babies, there's about a bajillion animals here. It's great, it's like out of a Disney movie. And this is what we need, because it's not just beavers that can't escape fire. It's everything that can't outrun, outswim, or outfly spreading flames. And these flames spread fast. Historically, there were a lot more wetlands that animals could find, and they could seek refuge in during fire. Today, we don't have very many. We can build them, that's true, but so can beavers. And if somehow you are not convinced yet that beavers are worth your time and attention, here's some dollar amounts of how valuable they actually are. So this study was from 2020, and they went through the ecosystem services provided by beavers and tried to quantify exactly how much value are they providing per square mile per year. And it comes in recreational hunting and fishing. It comes in greenhouse gas sequestration. It comes in water supply and water purification, habitat and biodiversity provisioning, and also that moderation of extreme events. And this figure here, $179,000 of value per square mile they engineer per year, does not account for wildfire. So add more, and then also remember this is 2020 and things are more expensive now, so add more. Beavers are doing a lot of work for us. What do we do now? What's the next step? Is it time to start airdropping them all across North America again? Again, unfortunately, actually, like this was a thing. This is Idaho, this is California. These two states have owned up to it. I think a lot more states did this. We were post-war and we had a lot of parachutes and beavers were moving into the cities. And someone in Fish and Game was like, you know what would be cool? Let's airdrop the beavers. So they packed them into boxes. There's beavers in that box. There's beavers in that box. They dumped them out of the airplane. The box opens on landing, and they're like, great, we got the beaver out of the city into the forest where it belongs. California was a little more diplomatic about it. They made this cute drawing. They also went and said, look, we're taking them out of places where they're harming our crops and levees, and then we're putting them where they can save water for fish, wildlife, and agriculture. And they were doing this, and then beavers went out of fashion, and they stopped. And when they stopped, a lot of places had healthy beaver populations, and they continued to grow. And some places had healthy beaver populations, and they fell off, and we lost them again, because we are not doing enough restoration to help them stick. And it's hard for them to recolonize the landscapes that are so changed today. So this is not the solution, and the solution is not also to just swap this out for a drone and do it again, but more automated. The solution is actually to be more intentional about bringing them back. We know bringing back beavers can be successful. We can bring them back to our watersheds. And South Dakota is doing a really good job about thinking about how we can do this successfully. It's a hard conversation. How do we bring back an animal that's chaotic and that causes conflict and that not everybody wants, but everybody does need? If we want healthy drinking water, if we want good fishing water, if we want drought resilience and fire resilience and flood resilience, we need beavers. What if we don't want our tree chewed? What if we don't want our things flooded? These are all good questions to ask and things that need to be thought about, but we do need to think about them. Because in 2012, there were 60 food caches in the Black Hills, and that was about half the watersheds here. I can tell you as a beaver scientist who censuses beavers all the time, 60 food caches is alarmingly small. And then, just 10 years later, it was down to 16. We are losing them. They will be locally extinct here if we don't do something different. And maybe that involves protecting them when we drop them off. And maybe that involves doing the restoration work ourselves and pulling a bit more of our weight. And maybe that involves education and outreach and trying to convince people that, yes, you should want this animal back. It definitely involves more compromises. Beavers chew on trees we don't want them to chew. What if we wrap it in fencing? Sometimes it works, sometimes it doesn't. There's answers to this, though. We don't need to throw up our hands and say, oh no, the tree's gone. I don't like the beaver anymore. The wrapping didn't work. This one didn't work because this is flimsy wire that was wrapped shorter than a beaver, so it reared up and squished it, and then it ate the tree. We can acknowledge this is a large animal. There's nothing like, oh no, we can't say the beaver weighs 80 pounds and it can crush this down. It can. So let's wrap these better. And it turns out if you do wrap them correctly, then it's 97% effective. We can also control flooding. Beavers are engineers, but so are we. If they're flooding somewhere that's not acceptable, put a pipe in the dam. We've engineered pipes, beavers haven't, which means this is very confusing to them, and they can't deal with it. So either they accept the pond level that you set, or they leave and go somewhere else. Either way, the conflict is solved and the beaver is alive. And we do need to bring them back. 16 food caches does not represent a self-sustaining population of beavers. We need to bring them back to the Black Hills, and we need to figure out the way to do that. Beaver trapping is sensitive. You have to bring the whole family. They work as a family unit. If you bring rando beavers and put them together, they'll fight. They're very territorial. How do you move these animals? The good news is there's a lot of experts out there that can help. I get asked a lot, what does the beaver future look like where we have all these benefits? And what's the number? Is it 15% historic population, 20%, 30%, 100%? We'll never get to 100%. It's impossible. There's so many more people on this continent now. But we can do better, and doing better is not about a specific number. It's about our attitudes towards beavers. What my beaver future looks like when I think about the ideal is it's people that when they go out and they see a beaver sitting awkward on the bank grooming itself, or building its dam, or chewing on a tree, their first reaction isn't, ugh, annoying, or ew, stinky wetland. Their first reaction is, wow, I am witnessing the animal that is second only to myself in its ability to engineer the physical earth. I am witnessing one of the most powerful earth movers that exists on this planet. Isn't that cool? And then after that, sure, if there's a conflict, deal with it. If you love the animal, watch it for an hour. But just that first gut reaction, we need to shift our attitudes because we don't have infinite allies out there to deal with fire and drought and floods. We have this one, we know we can work with it, so let's be more intentional about that. And with that, I'd be happy to answer any questions you all have.
Dr. Fairfax, when someone asks you a question, can you just make sure to repeat it?
Yeah, absolutely. Yeah.
What's the survival rate? And I would assume that depends on the severity, but after the fire goes through and such.
Yeah, great question. So what is the survival rate of the beavers after the fire goes through? At my field sites, the initial survival rate is very high. If they can get in a canal and swim home, these ponds, even if you get a little burning on the edge, it's not burning in the middle. They go hide in their lodge and they stay there. They do the same thing during heat waves. They hide out in their lodge a lot longer. So I do think they have a pretty good sense of if it's bad fire conditions and don't stray too far from home. After that first initial survival, there needs to be enough food. Most of the dams in my studies are preserving about 2.5 to 3 acres of riparian vegetation around them. And so if they have 14 dams, you times that by 2.5 to 3, and that's how much food they have. If that can balance off their food needs in the time it takes for the rest of the riparian to grow back, then they will survive. And I see that pretty often. What I also see, which can limit their survival, is post-fire. This is the patch, and it's isolated, and it's the only green area, and every single bear and its child and its mother is showing up. And there's one family of beavers there, and beavers are food. So we do see increased predation pressure post-fire, but at that point, it's ecology playing out, and if you have a healthy beaver population in the watershed, that's okay. I don't see very many examples at all of the beavers getting burnt. I hope I don't see any of them. It's kind of graphic to think about, but I'm sure it happens occasionally, just like occasionally they get squished by trees they chew down. Yeah.
How long does a beaver live?
Great question. It's how long does a beaver live? In the wild, a beaver will live about 10 to 12 years on average. They experience almost all of their mortality when they're young. So about half of beavers make it to adulthood. In those first 3 years, we lose about half of them. Then once they're adults, they are so big that even with their true predators like wolves and bears and puma, they can survive and escape most of those, and they are pretty good to go unless they're hit by cars or trapped by people. So they can live a good amount of time in the wild. Once they're 10 to 12, they start to slow down. It's easier for predators to get them, or they just get sick and old. But in captivity, they can actually live to be 25. So beavers are one of the longest lived rodents. Yeah.
Is there an estimate of how much water there is in that image relative to how much water we can see in that picture?
Yeah, so the question is what's the estimate of the relative amount of water we see to the water that actually exists in this image? So we have surface water storage in beaver ponds. Let's say that this is 1,000 cubic meters stored in these ponds. We would expect 2 to 5 times as much in the soil around it. And then as you enter your drought periods, that's what does flow back into the stream and maintain base flow during drought. Yeah.
I'm curious as to numbers, and I saw 3 dots on your last map. Is that location of dams, or how many dams do you estimate, how many beaver? Have we introduced any beaver, and if so, where do those beaver come from?
Yeah, great questions. So first is about these dots or these dams. How many beavers do we have? How many dams do we have? How do we get them? Do we reintroduce them? These are iNaturalist observations. So these are people who are witnessing beavers or beaver-chewed trees or beaver dams within the Rapid City area. And unfortunately, those are the number of observations I have. Granted, not everybody who observes a beaver will report it, but this is one of the best ways that we can help constrain our estimates of beaver populations that we get from satellite data. So if you do see beaver dams or beaver-chewed trees, take a photo, put it on iNaturalist. Scientists like me use it pretty often. This is way fewer than I would expect here. We are pretty beaver deficient in Rapid City and in the Black Hills, and we could have a lot more. Reintroduction is a great thing to do, especially if you have a whole family and you have a willing landowner. In most states, when reintroduction is done, it's taken either from urban areas or farmland where the beaver is not wanted, and they live trap them all and they move them in one day and then they drop them off. I'm not sure of the specifics of how it's being done here or in what capacities, but I know that reintroduction and relocation is something that's being discussed heavily as a path forwards. Yeah.
In the analog dams that have been built in the Black Hills, are any of those attracting beavers now?
Yeah, great question. So about the BDAs or Beaver Dam Analogs in the Black Hills, do any attract beavers, especially in the Black Hills? And the answer is yes. I have talked to folks here who've built BDAs in the Black Hills area who have had beavers come through and be quite attracted to those sites for 2 reasons. One, BDAs do some restoration work, so it's easier for the beavers. They see this as a better site overall habitat-wise. 2, because they interpret that as a broken and abandoned beaver dam. We do our best, and they swim up and they're like, whoa, nobody's worked on this in a decade. I can take over this new property because there's clearly not a beaver here, which is fair. I've seen beavers in my own work in a lot of different places. Sometimes they will directly move on top of the BDA and they'll start building on it. Sometimes they disagree with your placement and they'll build their own dam 2 feet away. Sometimes they will rip yours apart and then use it to build theirs. They just make lots of choices and it changes over time, but they do like the BDA sites overall and it's a great way to help them come back. Yeah.
You said earlier that they are related. How do you move beavers around when they got cousins living all over the place?
Great question. So it's about beavers being related and how do you move them around when they have cousins all over the place? The less glamorous answer to that is beavers are very resistant to inbreeding. So you can have cousin pairings and even to some extent sister-brother pairings, and it will not genetically harm the offspring if it does not happen often. So they can be in watershed with their cousins. The other thing that is helpful for beavers in moving them around and getting the whole family to be not just inbreeding somewhere is when a beaver becomes a teenager and it's 2 to 3 years old and it goes off to find its new habitat, they will travel anywhere from 5 up to 100 kilometers to find that. So they will really hoof it looking for new population. They can recognize each other by scent, and they would strongly prefer to not mate with their family. Yeah.
Are beavers a keystone species, and if not, why?
Great question. Are beavers a keystone species, and if not, why? They are. They are a strong keystone species. In the West, 80% of terrestrial vertebrates depend on access to a riparian wetland at some point in their life cycle. And beavers are one of the only things that will create riparian wetlands. So they are key for all of those. And then also key pollinators like bats, butterflies, lightning bugs. They really love beaver wetlands. Yeah.
Was wondering if you evaluated the life cycle of a beaver complex independent of fire and stuff. What is their natural evolution?
Yeah, so it's about the natural evolution of beaver complexes. How do they change over time in absence of fire? It varies a lot. In northern Michigan, we have a beaver dam that has been in place in the exact same shape for over 150 years. And it's just generation after generation. It's held water the whole time. And we know this because it has been drawn in trapper journals and then tracked in satellite images over time. It's incredible. And at that site, about 70% of the dams were actually 150 years old. That's not as common, especially in higher gradient streams and flashier streams. Here we would expect a typical beaver dam to last as is for maybe 7 years, and then it'll have a break in it, it might drain off a little bit, and then the beaver will fix it. So they go through these cycles of watertight-ish, and then leaky, and then fixed, and then leaky, and then maybe abandoned for a little while, and then recolonized. But once a beaver has decided a habitat is good, they will come back for thousands of years to that site. One of my postdocs has done ancient DNA studies and found that in Grand Teton National Park, we have about 7,000 years of continuous occupancy at some of our sites. Yeah.
What is the hell of a bad winter defined? How do you define that?
Sorry, what was the question?
How is the hell of a bad dinner? Wait a minute. Hell of a bad winter defined?
Oh, if they have a bad winter? Yeah, so for beavers, they handle winter by food caching. And if they have not cached enough food, then they're going to have to go out on the snow and try to find food, and they're very vulnerable. And so beavers are pretty tuned in to the fall as it starts to ramp up. Is it going to be extra cold? Are you getting early cold snaps? They cache more. They also thicken the walls of their lodge. So a lot of people in Ontario and in northern Minnesota will actually track beaver lodges to see if they're expanding a lot and use that to see if it can actually predict the winter. And it's not perfect. They're not weathermen. They're engineers. But they are doing the best they can, and when they feel a very cold fall, they prepare for a very cold winter. Yeah.
When it comes to like mortality rates and like the mention of beavers as a keystone species, how is their mortality affected when keystone predators are in the landscape?
It's a great question. So if beavers are keystone and then we remove keystone predators, how are their populations affected? It varies. Beavers, when they are babies, are predated on by a lot of things, actually. So river otters will eat baby beavers. A lot of birds of prey will eat baby beavers. Giant fish eat baby beavers. Anything, coyotes, bobcats, foxes eat baby beavers. Then when they're adults, it's really just bears, wolves, cougars. And when you take away those big predators, you are selectively removing the predation pressure from adults. And so you keep more of the dam building beavers that are large and functional on the landscape. But we have so few landscapes that are at capacity for beaver or for keystone predators that it's hard to actually know what would happen if we had an abundant beaver population with no predators. Nowhere except a couple of very small areas in the United States are at beaver capacity. And those landscapes that are, like Voyageurs National Park in northern Minnesota, has a really healthy wolf population, and the beavers are still at capacity. When you take away the wolves, they are also still at capacity up there.
We know that the water slows down and this increases the ability for the water to release the soil sediment. Is there research that indicates that that sediment that is there now is bringing in new plant types?
That's a good question. So if the release of sediments in the beaver wetlands, if that's bringing in new plant types, I think the best answer I have for that is also from our ancient DNA studies, where we find that as soon as beavers colonize a landscape, we do see a rapid transition from whatever it was into wetland biomes. So we see the arise of lilies, we see cattails, we see other native like swamp roses and things like that pop in really, really contemporaneously with the beavers. Whether they're actually physically bringing seeds from downstream with them, whether the sediment there already held these in the past and it's being re-redded and sort of re-released, we don't know the exact mechanism yet, but we do know that the presence of beaver does cause a significant shift in the local ecosystem. Yeah.
Given the overall low numbers of beaver population throughout North America, and the fact that some of those areas, Black Hills, for example, are quite isolated from other populations, will the genetic diversity of the species as a whole be able to recoup?
Great question. So with beavers being so isolated from one another now, can the genetic diversity be recouped and can it be maintained? This is a really big question. We don't actually know how much genetic diversity we lost when we had the fur trade. So it's really possible that beavers had a lot more genetic variance amongst themselves, but we haven't mapped the beaver genome entirely, and we don't have enough data from regional samples to say, is like a Black Hills beaver actually any different genetically than a Minnesota beaver? And if they are, can we mix them together to increase the genetic diversity, or are they all basically the same descendant of some beaver that survived the fur trade 100 years ago? We haven't seen any negative effects or genetic bottlenecking in any of the locations in the United States, even if they are really isolated. In California, when they did reintroductions in the 40s and 50s, they would put 40 beavers in, and that was enough to maintain strong genetic diversity. They ultimately do spread out. They'll travel miles and miles and miles and miles to find other beavers, with mixed success sometimes, but they are very driven to genetically diversify as best they can. Yeah.
I know of a beaver dam in Michigan that was dynamited
Mm-hmm.
by the Corps of Engineers or the state, primarily because people complaining of the private property was backed up with water. Have you seen much of that in your studies, where they were blowing up the dams because people complained?
Yeah, so the question is, have I seen places where they're blowing up the beaver dams because of human conflict? And the answer is a big yes. Wisconsin and Michigan are some of the biggest users of that method of dam removal. They use tannerite, they lace the dam with tannerite, they blow it up all at once. I understand removing dams that are causing significant flooding, and there are ways to do that that are ecologically and geomorphically balanced. Notch the dam like it would happen normally in nature, drain off the water slowly, then pull the pieces apart slowly. When you blow up a beaver dam, you're basically simulating 100 to 1,000-year flood. We've seen beaver dams withstand 400-year floods and not break that way. So when we break them all at once, we're basically simulating this extremely disastrous event, and then we do it every single year on a stream. And then people wonder why the stream is like not doing so hot. And it's because you bombed it for 5 years in a row. But this is still happening in a lot of places, and it is something that I advocate against, because even if the dam needs to be removed, that's probably the worst environmental way to do it. Yeah.
After beavers have been reintroduced to an area, how quickly does it start to increase the biodiversity of the area? And also, in that same vein, does it does it stop the degradation, or does it reverse it?
Great questions. So after beavers are recolonizing an area, how fast do you get those biodiversity booms? And then also, do they stop degradation or do they reverse it? So first on the degradation, they reverse it. A great example is Bridge Creek in Oregon, and it was super, super incised, extremely high flows, some natural beavers there, but it was so incised that even the natural beavers were struggling with those streams because they couldn't even build up to floodplain height. So people put in posts to help those beavers and then also built a boatload of BDAs. And within a few years, they had fully restored that stream, and it was no longer incised. It could withstand the floods. The beavers didn't need our help anymore. Huge success. In my own work in California doing game camera trapping, we watched beavers colonize a site, and we went from 12 species identified on the game cameras, and these are going to be larger vertebrate species, to 72 the next year. It was mostly birds at that site. We got a huge number of birds. We were not counting fish. We were not counting insects, which are the other two that people usually want to know about. But birds and mammals, we saw a massive increase in that biodiversity, and it was maintained and continued to grow as the beavers stayed. We brought back some keystone predators to that site that left the beavers alone enough because there were enough deers and other things that were easier to catch. And I think they just had their first bear come back to that site last year. So it's really doing well, completely different than what it was before the beavers were there. Yeah.
My son wants to know if a beaver has ever started a fire by rubbing two sticks together.
Excellent question. A beaver has not started a fire by rubbing two sticks together, but a beaver has started a fire in Canada by chewing down a power line. And so that beaver was maybe a problem. And it did cut down a power line pole, and that power line did spark and start a small wildfire. But guess what? There was a beaver wetland there, so it didn't spread very far. So I'm going to give him a pass on this. I don't like to put too much of a spotlight on that happening. It's very rare, but they have started fires. Yeah.
When you talk to communities about like reintroducing beaver, is it more apathy that people don't really think or care about it, or is it more resistance that people are actively hostile to the idea?
So the question's about when I talk to communities about reintroducing beaver, is the problem apathy or is it resistance? And that varies community to community in a big way. So some places I'll go and I'll talk about beavers and I'll show this data and it's just like, oh my God, I had no idea. Like I've seen beavers my whole life, I had no idea. And that's totally fair that people had no idea because this is really new science. And this is also something that we haven't been able to study because we haven't had as many disastrous fires overlapping with places we had beavers for a really long time. Sometimes it is resistance. There's a lot of deeply held beliefs about what streams look like. Like the whole field of river hydrology has beliefs about what streams look like, and most of those don't include wood, and they don't include beavers. And so when we want to bring these things back, it feels like a huge change. And it is a fact to say, my stream hasn't looked like this for 120 years. Why would I put beavers and logs in it? It doesn't look like this. And it truly hasn't looked like that for 120 years. It did look like that for 10,000 before that, but nobody was there looking at it who is there today telling me that it looks wrong. And so I think there's sort of this ecological amnesia phenomenon that Ben Goldfarb has talked about, where people just have this shifting baseline of what their streams are supposed to look like. And then when you introduce something that is as radical and dramatic and over the top as a beaver transforming it from stream to wetland basically overnight, that feels alarming. And that triggers people to feel defensive because they genuinely want to protect their streams. And they just don't feel like beavers are the right way to do it yet. And then I keep talking and all day. Like, that's what I do. And hopefully we get there. And sometimes we never do, and that's also okay. But sometimes we do. Yeah.
So, have you had any insights on livestock grazing and interacting with beavers?
Great question. So it's about insights on livestock interacting and grazing interacting with beavers. I have lots of insights, and this is one of our biggest research questions. So it's a bit of a coincidence that I'm coming through here in person in South Dakota, because tomorrow we are going to be in Wyoming, spending about 2 weeks looking at the overlap of grazing and beavers in a place that is at beaver capacity. So whatever's happening there, and however it established, we have active grazing, we have 750 beaver dams, and it's coexisting great. We also have a site that has active grazing and that the beavers are being actively driven out of. And so we're trying to figure out under what conditions do we have really sustainable and great coexistence between grazers and beavers. We know it can happen. They've dealt with grazers for their entire evolutionary history. But in what situations is the pressure balance wrong? How many cows is too many cows? How much time is too much time? How fast do you have to move them? Does it matter if you use fencing or not? We don't have solid answers on those yet, but in 2.5 weeks, we'll have data. Yeah.
My question was kind of around fencing, but you don't have the answers for that yet. But I guess when it comes to trying to get willow to reestablish in the floodplain for like PDA sites and restoration, when you're looking at like old willow stands that have a lot of overgrown shoots that clearly have been pruned by beaver and God knows how long, and so should we be going in there and pruning old willow stands that have these like dead stalks? Would that help the wetland regenerate?
Great question. So it's about older sort of overgrown willow stands where they haven't had beavers chewing on them for a long time, and you've got dead branches on there. What do? Do you trim it off? Do you prune it? I would say that the best thing to do is to try to be the beaver. And when I visit sites that have a lot of beaver occupancy, you have stumps of big old cottonwoods or willows or other poplars or things like that. And they are chewed, and there's 1 trillion shoots that came out. And then you come back the next year and half of those are chewed and half of them are bigger. And every year you come back and it's actually continuing to grow in biomass. And so that's what we like to see, the frequent coppicing. These trees have also lived with beavers for 7.5 million years of dam building, and they have lived with 24 million years of tree chewing. They have defense. When a tree gets cut, it puts out compounds that are really difficult to digest and taste bad to beavers until it has full bark on it again. And so there's a natural way to stop that overgrazing process. And most of the plants that beavers chew do regenerate from their cuttings. So the stump will grow back in many of those cases. And as the beaver's dragging this branch around and dropping little sticks everywhere, those take root. If you pick up those little sticks, they have little roots growing out of them, and that's how beavers sort of regrow the landscape. I should have put a picture of it in here. I have some really cool grassland photos, and it looks like just a great sea of shortgrass prairie, except a curly line of willows goes through it. And if you take a shovel and dig in, it's an old beaver dam. And the willows are growing where the beavers had used the willows, which is to build their dams. Yeah.
Really quick, if I understood her question correctly, Irene wanted to know if when beavers are chewing down a tree, are they accidentally eating bugs too? I think it was kind of.
You know, that's a really good question. When beavers chew down a tree, do they accidentally eat bugs? I'm the first person to stand up here and tell you that beavers are hardcore vegetarians, and they are just going to eat bark and pondweeds and grasses. But you know what? People eat bugs even if they're hardcore vegetarians on accident sometimes. So I would not be surprised if a beaver was really going fast at a tree and got some bugs in if it didn't notice and just kept eating. Yeah.
Really quick, what you've seen in terms of, looking at fire and beaver, like they create a refuge area, but like what about post-fire? What's the difference between one of these systems that's maintained this complex versus a stream that didn't have any beaver, like when you get the next big rain event or
Yeah, great question. So what is happening here post-fire instead of just during fire? Post-fire, we see a few things happen. Number one, these are massive catches for sediment and ash. So it slows down in here, it can settle out. There's a really good example in Oregon in the bootleg fire of emergency post-fire BDAs being installed on streams, and those were installed to help catch ash, to help it not coat all the fish gills and kill them all. And it worked. They were able to protect a lot of fish with that, and the BDAs filled up the whole area behind them with ash, which sounds kind of gross, but I would rather have it become soil again than have it stay suspended in the water column. The other thing we're starting to see and just beginning to collect data on is recovery sort of bouncing out around the landscape from these. Are these truly the preserved seed bank? You would think so, because we have preserved adult species of willow and reeds and grasses, but then also these upland species. So if you want to recolonize the landscape with natives and not invasives, I would think these would help. And there was at least one master's thesis out of Eastern Washington University that agreed with that. And they did find higher abundance of native species post-fire if you had beaver dams present. All right, I will take more questions afterwards in person if you want to ask more, but thank you all for listening. It was really great talking with you.